So last time we talked about exponents and how you can simplify an expression that has exponents, and today we're going to be talking about how you can simplify radicals. Now, just as a reminder, radicals are the opposite operation to exponents. So for example, if 1 squared is equal to 1, 2 squared is 4, 3 squared is 9, and so on, and then over here on the right we have 1 cubed is 1, 2 to the third is 8, 3 to the third is 27. If you were to write this as the opposite operation in radical form, this would be the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and so on. When you get to the cubes, then you can write these as cube roots instead of square roots. So this would be the cube root of 1 is 1, the cube root of 8 is 2, the cube root of 27 is 3, and so on. Alright, now how do you do this on the calculator? So generally on calculators, for square roots, you want to press the second button and then the button that says x squared, and that will give you square root. Now if you have other roots, for example a cube root or anything higher than that, then you will need to use a different method. Now for a scientific calculator, generally if you type in 3 for cube root, second, and then the button that has the little caret symbol, then it will bring you to the cube root of, and you can type in whatever you're taking the cube root of after that. For a graphing calculator, generally you would use the math button and then either go down to 4 or 5. Okay, so let's take a look at example 1. These ones you can probably do without a calculator. So the square root of 36. What this is asking you for is, what number do I square to get 36? Well, the answer here would be 6 squared is equal to 36, so our answer here is 6. Next we have the cube root of 8. So this is asking you, what number do I cube in order to get 8? What number to the third power will give me 8? Well, 2 times 2 times 2 is equal to 8, so our answer here would be 2. Alright, next we have the cube root of negative 64. Now here, since we're working with a cube root, again, what number multiplied by itself 3 times will give me negative 64? Now we know that 4 times 4 times 4 gives me 64, but this is negative 64. So this would have to be negative 4 times negative 4 times negative 4 to get negative 64. Alright, and the last one here we have the square root of 4 squared times 2 squared. I'm going to start off by simplifying this as much as I can. So 4 squared is 16, 2 squared is 4. 16 times 4 is equal to 64. And the square root of 64 is equal to 8. So 8 here is my answer. Now notice here that we did have a negative under a cube root, but you can't have a negative under a square root. So just as a note, even roots cannot be negative. However, odd roots can be negative. And the reason for this is when you're taking an even root, that means a number multiplied by itself an even number of times. Now if you have a negative number, a negative times a negative, that has to be positive. So there's no way that you can find a number multiplied by itself an even number of times that won't be positive. So when you take the even root, it cannot be negative. Odd roots, however, can be negative because if you're multiplying a negative number by itself an odd number of times, that's going to be negative, whereas an odd root multiplied by itself an even number of times, that's going to be positive. So odd roots can be negative. Alright, next, when you take the square root of a number or a variable with a power, you can rewrite it this way. So if you have the nth root of x to the r, that's the same as x to the r over n. Now just as a note, generally with square roots, there's an implied 2 there, we just don't usually write it. So if you're ever wondering, well, there's nothing written there, well, actually, there's a 2 that's always implied there if there isn't anything written there for n. Alright, let's take a look at some examples. All right, in this first one, we have the square root of 25 squared. Now, instead of trying to find 25 squared, I can rewrite this as 25 to the 2 over 2. The implied 2 that's on the outside goes into the denominator. Now, 2 over 2 is equal to 1, so 25 to the first is equal to 25. All right, this next one, we have the cube root of 64 squared. Now, if you'd like to, you can absolutely take the cube root of 64 first before squaring it, like this. So the cube root of 64 is equal to 4. And then squaring that, we get 16. All right, the next one, we have the square root of x to the 6. I can rewrite this as x to the 6 over 2. So since the 2 is implied on the outside as a square root, I can write that in the denominator of the exponent, so 6 over 2. Now 6 over 2 is equal to 3, so this is equal to x cubed. All right, next we have the cube root of x cubed y to the 9th. So for this one, again, we have the 3 on the outside there, so I can rewrite this to be in the denominators of the exponents. Now I have to do that for both. So this is going to be x to the 3 over 3 and y to the 9 over 3. Now x to the 3 over 3, that's x to the first, and y to the 9 over 3, that's y cubed. So our answer here is xy cubed. All right, this next one, we have a square root inside a square root. If you have something like this, try to simplify inside as much as you can. So start with the square root of 256. Square root of 256 is equal to 16. So now we have to take the square root of 16, and that's equal to 4. So our answer here is 4. All right, the last one we have here, the square root of 50 minus 5 squared. So we can go ahead and simplify inside of the square root first. So 5 squared is 25, so this is square root of 50 minus 25. 50 minus 25 is equal to 25, so this is the square root of 25, which is equal to 5. So 5 is our answer for this last one.